transition into our next segment, a panel discussion titled Quantum Accelerated Computing, the Future of Hybrid Systems in Quantum and Classical Computing. A.K. Nath, Senior Advisor for Quantum and HPC at C-DAC. Sir, we request you to kindly join us on the dais and moderate the session. Who will join Colonel A.K. Nath for this discussion? Shri Rahul Neiwal, Scientist MeitY, Shri Amit Saxena, Scientist C-DAC Pune, Shri Amit Srivastava, C-DAC Pune, Scientist, Shri Vivek Neiwal, Scientist C-DAC Hyderabad, Shri Nishant Shekhar, Scientist C-DAC Patna, and Shri Abhishek Tiwari, Scientist C-DAC Noida. Let's welcome our panelists and kick off this insightful discussion.
Good evening, everybody. So welcome to this last event of the day and the seminar. In fact, so much has been said and presented all during the seminar by very eminent speakers. You by now are very clear that despite what has been said by Jensen and what has been presented, that quantum advantage is very far away, quantum supremacy has been demonstrated. Quantum computing is definitely here to stay, and there are a lot of developments happening in quantum computing which have been brought out by various eminent speakers. Annealers have been are being used for various optimization tasks like flight path optimization and loading cargo into ships, so many other things. A lot of developments happening to improve the performance of quantum computers. A lot of developments happening to realize quantum computers at room temperatures, because this cooling is a great roadblock in the development of quantum computers. Various technologies are being developed and announced day in and day out. So the whole world is very actively working in the area of quantum computing. And what is more noticeable is that in some sessions it's been talked about that the algorithms and use cases, it has been noticed in presentations of companies like IBM and big companies like Infosys and Tech Mahindra. There are companies, unfortunately not in India but abroad, big companies in the financial sector, in the pharma sector, in the aerospace sector, taking the names, Boeing, Mercedes-Benz, Morgan Stanley, and so on and so forth, which are very rapidly converting their operations into quantum programs. Now, why should they do so if quantum advantage is so far away? That is the question we often ask each other. Is it something like the race to Y2K which is happening all over the world? It seems so. But then when we look at all the kind of things, statistics, all the numbers being presented and the errors and how many qubits will it take, physical qubits will it take to actually realize one logical qubit, and where we are today, we are not even at the 1000 stage. Dilution refrigerators are at a stage where we cannot accommodate more than 200 to 300 or 400 orbit density, high density wiring, maybe 600 qubits. Optical connections between various quantum QPUs have their own problems, and so on and so forth. But still this is going on. So, and the subject of the seminar today, hybrid classical computing, quantum classical computing. let me tell you that the whole world has taken cognizance that quantum computers and classical computers, HPC, have to coexist for a long time. And hybrid quantum classical systems are not only going to be used for running use cases or algorithms. It's already been shown that they are already being used for running programs for the housekeeping and the system engineering programs, error mitigation, error correction, tuning, characterization, and so on and so forth. So already the classical system very tightly bound to the quantum systems. And the developments all over the world, already there are countries like US, Finland, Germany, Spain, where these developments are happening. Israel, the Israel Quantum Center, the Barcelona Supercomputing Center in Spain, Jülich and the LRZ in Munich, Finland, where they have their supercomputer called Lumi, which has been integrated with the Helmi, which is their quantum computer. So all these places in the world, at least this thing is taking place right now as we speak. And not only that, all over the world, people are not only looking at superconducting computers in their supercomputing centers, but they are also looking at playing around with other technologies which are more promising. One never knows which might overtake the other in time to come. The neutral atom-based supercomputers, quantum computers, or the photonics-based quantum computers. And in one of the supercomputing conferences which I attended, there is a company from Australia, Quantum Brilliance, which claims that they have already built stackable quantum computers based on NV Center Diamond. So these are some developments which are taking place rapidly in the world today, and therefore we should not rest and let go of any facet of quantum computing. So having said that, I would like to throw open a question to the panel that while classical computing is well established and optimized, quantum computing still being in the early stages, how do you see the role of hybrid quantum classical systems in next 5 to 10 years, both in India and in the world? So anyone of you can take on this question.
Good evening, everyone. Regarding your question, sir, that where is hybrid going? So let me tell you what NVIDIA is doing, so we can come back to this hybrid and classical. So if anyone knows that NVIDIA chips are the de facto GPU chips, but do you know that NVIDIA is not very power efficient, and this is the thing that Apple and NVIDIA have in them, a problem where Apple doesn't want to use NVIDIA but is forced to use it. So why is so? The thing is, NVIDIA has developed CUDA. And what is CUDA? CUDA identifies which part of your problem is going to be parallelized or put into parallel system and which part is to be done in serial. At present, classical computers have achieved their stature in computation. Quantum is ongoing, but we have to decide which part of thing is going to be done in classical of a problem and which part has to be offloaded to the quantum. And this is a very dynamic system, that considering a problem that this part is the classical things, classical systems will be doing, this part of the problem will be done by the quantum systems, and those decision making has to be done in next 5 to 10 years. And we have to develop systems that identify it automatically, not statistically. Means not a static way that this is the algorithm, only to do it. So AI is also going to come into play, where AI will improve upon it, that okay, in the dynamic environment, I will place at a certain time problem part to classical computations involving CPUs, GPUs, and I will put the next part into the quantum computers, and as a co-processor, both will come together and give out the final results. So this is one area where we think C-DAC has also initiated its activity of developing through quantum accelerators the distance, means how to optimize this part. So this was from my side.
Yeah, hello. I just want to add, or just to continue what Nishant has told. Like, in case of CUDA, in case of GPU, we already have a built-in library, or you can say a built-in firmware where on which it is very easy to port the application. So in case if we are going for a hybrid, platforms which consist of quantum computers plus, our classical computers, we need to see that, it should be hardware and software agnostic. That is very required. Like, means tomorrow the backend hardware may not be only a GPU, it may not be only a CPU, it can be any hardware, but the software developer who is only knowing Python or he is only programming using C++, he should not worry what is going on the backend. It should be totally agnostic and interoperable platform has to be built. That is also one of the goals what our this quantum accelerated the project what we are doing. We have combined multiple hardware using vector, GPU, FPGA and CPU. But on the top of that, we are trying to make a software layer for which the developer don't need to see that whether they are going to use which kind of hardware. The software should be capable of porting the application which is best suited for the hardware. So that surely is going to help in this. Thank you.
Just a second. I would like to add, we are talking about NVIDIA and the framework that it provides. So I think it's a CUDA-Q framework that right now NVIDIA is providing for this hybrid classical kind of an environment where you can write the code and it distinguishes between quantum part and even like the GPU part or the normal classical part. So right now what they have integrated is, in the framework they have integrated simulators, quantum simulators, and you can make a program and part of your thing will be offloaded to the simulators. And the next step to it is instead of using simulators, how to integrate your actual quantum computers, and that is right now loosely coupled because we know that the quantum computer setting is very huge and it requires a different infrastructure. So your main HPC systems in the classical system, they reside in a different environment and your quantum system in different environment. So they have a lag between them, and right now what the current industry is trying to do is to make them as tightly coupled as possible so that this the delay or the things can be more optimized.
I think there is a need of development good software stack that will be compatible with hardware. I think NVIDIA and some companies are already working on that. So that is also one more important thing.
Yeah, to complement these all things, I would like to add. So we need a quantum operating system. So earlier we used to see we have RISC architecture, we have CISC architecture, we have different type of processors, and based on different x86 architecture, ARM architecture. So all those architecture were there, and the operating system used to shield everything. So once we have a quantum operating system, we can see that this can work seamlessly with the underlying quantum computers, which is it can be based on any form of photonics based quantum computer, neutral atom based things, and it may be superconducting based things. So whatever form of qubit is there, our operating system is going to handle it, and it can be remotely, or it can be a distributed operating system. So we can see what sort of things it can do. So, but the user perspective, user should not know what things we should offload. So there's a requirement of AI which can segregate this, as rightly said by Abhishek, that we should know that AI automatically deciding which part is quantum, which part is classical, and the hybrid algorithms we have to do. As algorithm development has to be there, so we need new algorithms which are inherently hybrid. So this sort of development is required.
So thanks. I think it's a very exciting question. So I'll also add something to my own question. Actually, there are two schools of thought. People have brought out about NVIDIA, and they are experimenting in reducing the latency between the quantum computer or the controller of the quantum computer and the GPU card, which they have tried to interconnect using the InfiniBand proprietary network they have, and they claim latencies of nanoseconds. On the other hand, the other school of thought says that they don't care about the latency, but they can even, from a long distance integrate a quantum computer with a supercomputer even through the cloud, and leaving everything to the orchestration layer. So there are two schools of thought, and both are equally, both are adopted by equally prominent companies in the business. One is by IBM, the other one is by NVIDIA. So we have to see how things go forward. As far as C-DAC is concerned, we have embarked upon a journey where we try to actually port the simulator software onto different cards and try to make them tightly coupled with the supercomputers. So this QSIM, which we have developed, or rather IC Bangalore, C-DAC and IIT Roorkee have developed, that and the Qiskit have been ported on GPUs, on vector cards, on FPGAs, and all these, we try to realize how many qubits we can get, and we're trying to see how we can run various algorithms and use cases on these, and couple them with HPC and see what are the results. So this is currently happening in C-DAC, and it's a very interesting exercise which is taking place. So all the people you see in front of you are all working in this area. Someone is working on the FPGA, someone is working on the vector card, someone is working on the GPU. And C-DAC has also developed a software stack, as we are talking. It's going to be launched soon, so I'll reserve the name of the software stack. And right now it is working well with superconducting and photonics qubits, and we're trying to make it totally technology agnostic. And therein we are trying to build this functionality of the orchestration layer, where the job can be passed on to either a classical or a quantum computer without the knowledge of the developer. So that is one of the endeavors which is happening. So let's see how we can achieve it and when we can achieve it. So this is very much in the offing. So now I would like to ask our representative from MeitY, Mr. Rahul Neiwal here. MeitY has been supporting us in these endeavors in a very big way, and we're really thankful. In fact, very soon, God willing, we'll be having a reference facility in the country, thanks to MeitY. So, what do you see is the potential in this area in the next, few years, and which are those initiatives which you feel or MeitY feels should be supported in the coming years in this, very challenging field of hybrid quantum classical computing?
Thank you, sir. First of all, for coming to your question, I congratulate C-DAC Pune and Direct Pune to organize such a beautiful symposium. As you know, we are living in the era of disruption of technology, where the disruption is overnight. The live example is a DeepSeek. These type of symposium is the need of the time, and I request C-DAC to just organize this frequently, the symposium. These symposiums not only create the awareness, but also give the chance for deep dive in the technology. We have also visited the lab of Vijay Raghvan sir and G. Raghvan sir and Sanju Sardar lab, DRDO lab, and definitely there is a wonderful work is going on in the photonics and quantum computing, quantum communication. Definitely is a great work is going on, and we need this country need this work. So now come to this question of sir. The MeitY has already says the quantum ripple as a 5 year ago. We have initiated the first in the country where we have initiated one of the program to build a quantum simulator. So where in our roadmap we have first we envisage that we have to first create the capacity building. So we come up with the QSIM and C-DAC Bangalore and ISC has Hyderabad, ISC and IT Roorkee as a part of that project. Now the QSIM is live and around 600 students are registered on that platform and has the chance to head out training on the quantum programming. I invite you all the student to please explore the that portal, and this is the indigenous one where you get the touch of the quantum programming. This is the first interface of the computing, of the quantum computing. Ahead of it, we also plan to build the infrastructure of quantum assisted infrastructure needed for the quantum research, and $1 million required to invest in the research because it's capital intensive. So for that one, we also initiated a project for Center of Excellence in Quantum Technology in the reputed institute by ISC, C-DAC and MeitY, where we have built 4-qubit quantum computer, superconductive based quantum processor and elementary component quantum communication, and around 10 activities already going on in this project of Center of Excellence. And this is one of the first Center of Excellence of this kind. We also initiated some project in quantum communication. There is a Mahan is the first test bed for employed as for the QPD deployment. And recently we have another project for drone with a drone quantum communication, and this project is quantum state, and with this symposium is going on is also initiated the MeitY. Now, as far as the hybrid quantum classical computing is one of the crucial steps in the quantum computing, this initiative of quantum computing, that we have to do some research in the quantum classical thing. As you know, as you are aware that Government of India has two major missions. One is the National Quantum Mission, where we are trying to build the facility and capabilities in the quantum technology in the 4 pillars: computing, communication, sensing, and materials. And one of the main aim in that mission is to build a quantum computer, indigenous quantum computer, with around 50 to 100. And also in MeitY we also have one of the mission, National Supercomputing Mission, in which we already developed penta-scale HPC systems, and we are planning for the exascale HPC quantum system. So we have both. In the upcoming time, we have a exascale HPC system, also as a quantum computer, indigenous quantum computer. As Nath has already told you, that MeitY is also planning for a reference facility where we have 50 to 100 qubit quantum computer. So naturally, there is an alignment that we go for the quantum classical interface. And definitely, whether there is a superconducting or it's an ion trap, it's a photonics, the HPC will be there. Without HPC, no interface, no implementation technology can run. So HPC is a control one, which is required for all the implementation technology. So, the plan of the government is to initiate both the quantum facility and the HPC and classical computing to integrate them to enhance the computing capability of the country. We also come up with some of the new projects in which we are planning for the indigenous development of hardware for the computing hardware, and some astronomic researches like that for the cryogenics control electronics, which are the very niche area of this technology. So there's a planning stage, and we hope we soon become with some indigenous quantum computer.
Thank you, Rahul. So, Amit, you've been leading this efforts in the quantum-based accelerators in C-DAC. Could you highlight some of the advancements made in integrating quantum-based accelerators with the HPC?
Yeah, thank you, sir. I think the symposium itself, we are working under this quantum accelerator project, where, as rightly mentioned, we started with the simulator. The base point of all this thing is a quantum simulator. That was a 12-qubit simulator QSIM, and that was jointly developed with the IIT Roorkee and IISc Bangalore. And it is available at qctoolkit.in, freely available. You can access it from the Google account also. So if you just type qctoolkit.in, it is available. Now that was a very much good start point for the students to develop a lot of algorithm, to learn a lot of things in the quantum computing, and we have done a lot of trainings on this QSIM. And finally, many students have been trained on this. Now, the problem that we're facing, that it was supporting only 12 qubits or 18 qubits. So we have to enhance some number of qubits. So we thought of, why can't we take our accelerator, which we are generally using in our HPC? Can we take the accelerators like GPU? Can we take the accelerator like vector, FPGAs? And can we enhance them? So we have deployed this QCM, we have deployed those simulators on our HPC-based systems and tightly integrated with our supercomputers. So this project conceptualization, now we are going like in GPU, we are getting 30 qubits and more. So in that way, we are able to enhance the capability and we are able to reduce the time of those execution, because the execution simulation, if it is not on a quantum computer, on a classical, it takes a lot of time to execute. So based on that, we are able to reduce the time of the simulators, and we are successfully achieved it. So take this forward now, we are trying to integrate it with the HPC and real quantum computer. So all these transpilers, compilers and all those aspects that can be reused in the HPC quantum integrator as well. So these efforts that we are doing with the classical system right now, it can be done with the quantum system, and once we have a quantum reference facility, we will be able to integrate it with our HPC, and finally we are going to have a HPC quantum hybrid things. We have tested VQ-based algorithms successfully. We have made a simulator-based environment, we have made a classical environment and quantum environment, and we have tried to benchmark this VQ-based algorithm, which is a hybrid type of approach. And we are successfully able to do it, and we have mentors like Professor Amlan Chakravarti from University of Calcutta who has verified it. So these type of things we are doing, and we are moving ahead with the HPC quantum integrated system in the future in that aspect.
I have it. In the quantum accelerator, we are aiming for the 30 qubit quantum simulator, and these project is not only for the development of technology. We are also aiming for the capacity building. So around 600 plus manpower will be trained during the project, and already we have trained around 6,000 plus in QSIM, and in quantum accelerator we are also planning for capacity building. So I invite the student here to please contact this person, Amit Saxena ji is a very valuable person for the quantum perspective. So how do we train? How do you come forward for this research, and what kind of portal or what kind of facility you have to use? Apart from this, I also mentioned here, we also initiated one project is quantum machine learning. There's a lot of things going on in the this domain, and we also have a presentation on the quantum AI. And when the quantum and AI will come up together, believe me, it will totally change the scenario. It will totally change. And definitely you have aware about the deep seek news where 1/6 of the GPU use can make the 600 billion downfall of the NVIDIA, and that news that made. So when the quantum will come, the machine learning and AI scenario will completely change. So sensing this, MeitY has already initiated a project, is quantum machine learning, in which around 9 institutes come together, and we have different quantum machine learning application. And it not only academia, we also try to come up with the startups and industry to collaborate on this project. So I request you to please have this in your mind and explore these things, because this is the new future, this is the coming future, and this is and this is not beyond. This is not thing that it's come after 20 years or 30 years. Believe me, it will become next in 5 to 10 years. The reality it will become the reality.
What are the biggest technical bottlenecks which you see in making quantum classical computing a reality?
Sir, though hybrid quantum classical quantum computing aim to leverage quantum processor along with the classical, but there is still some bottleneck like latency, like you were saying that we are working on that. So we face latency at the time of transfer of data between QPU and classical system. So that can be handled using several pre-processing techniques. So, and next, noise and error correction. As you know that quantum computers are prone to decoherence, making it difficult to maintain accurate computation. So this is one major bottleneck. And next, scalability is also a major part that is bottleneck, and integration of various algorithm and software integration. So we have to develop such type of algorithm so that some part has been handled by classical system, so that less interaction will be taken so that it can be increased in the speed. And one more thing, lack of a standardized framework to write scalable hybrid application. So these are some things which are the bottleneck in developing the hybrid classical quantum system.
Thank you. Quick question for you, Vivek. How can good software frameworks and middleware facilitate better integration between quantum and classical?
Actually, middleware frameworks, anything that goes from an application layer to the lower quantum systems, anything can be classified into the middle level system. But right now, if you see, because these middle layers are mostly classical in nature, and we are very strongly into the software programming and all, you can see that all the frameworks that are rightly or currently available, maybe it's Cascade, Strawberry Fields, or Pennyline and all, they have seen that they have made the life of a developer, specifically an application level programmer or the algorithm level programmer, quite easy. He does not have to think too much about how this thing will be running onto the system, and I believe like this will keep on improving more and more. Specifically the compilers and all, they have also been optimized and all, right? So every framework has its own compiler or a transpiler that transpiles the code very efficiently, and even you can make the circuit with less and less depending upon the optimization algorithm and the classical resources that are available. And I think it's going in a very right direction, and we are almost at a very good position in terms of all the classical frameworks that provide this hybrid quantum integration right now.
Nishant, if you would like to comment on error correction, error mitigation, and how hybrid systems would help in making things better.
Sir, error correction or noise mitigation is actually a physical problem. So hybrid system, what they can do is like you have a large traffic and you still have to navigate to your home. So hybrid system will create that algorithm or modify the algorithm to navigate that noise to reach an outcome. So there is a human intelligence and artificial intelligence that need to be incorporated. In terms of algorithm design, it will be human intelligence. In terms of reducing number of gates, the way connections and entanglements happen on different qubits, those will take into account what noise they are going to face, and then derive the possible best solution, so have to reach a particular set of answers. So all those computations need to be done on classical computer, cannot be done on quantum computers. So that's the only way hybrid will come into play.
My last question to Abhishek. from a hardware perspective, what advancements are needed to make hardware hybrid systems more scalable and viable?
Sir, I have already just now told like it should be, a hardware agnostic kind of system is what we should expect. And accessing a quantum computer will not be, accessible for everyone, even after 5 years, 6 years also once it comes. So the existence of hybrid quantum systems will always be there because they will be the first emulating platform for quantum computers. Like if someone is going to make a chip or a SOC, they have some kind of tools, EDA tools, or tabletop kind of board on which they use to test it, and once everything works fine, they take it to the real system. Same way, this existence of hybrid quantum systems will always be there once quantum computers comes in picture, because they will be the first step for testing the algorithms and checking it hardware wise also and software wise also with respect to optimization and NP-hard issues. Thank you.
So thank you very much, and with the help of this panel and the next, in the past half an hour, I think we have tried to bring out the subject of this hybrid quantum classical systems and the various aspects concerned about them and the nuances about it to the audience, and I hope something has gone forward and the subject has been conveyed. In fact, the integration is going on as we speak today at various levels, at the network and the hardware level, at the software level, and software level not only at there are notions that both the operating systems, that is the classical operating system and the quantum operating system should coexist on the same platform, and that is what is being tried when this NVIDIA card is being integrated with the controller. And also a very tight integration at the higher levels, at the orchestration layer. So in effect, you would see quantum computer as an accelerator to a supercomputer, just like a GPU or a vector card on an FPGA. So that is the ultimate aim of this hybrid quantum classical systems, which will be realized very soon. So with that, we thank you for being a very patient audience, and I see a lot of students here, very enthusiastic students, still some of whom are awake. So thank you very much. And with the permission of Dr. Sandhu Sardar, I think I would like to leave one food for thought with the students. The question I asked you, that if there was a very interesting aspect, not dealing with the subject of this panel discussion, but he brought out that you all are developing, in the quantum technologies are going into the weapon systems. So I would definitely like to motivate some of you to try and apply quantum physics in the development of EMP weapons, electromagnetic pulse weapons, which is a very, very potent weapon. It doesn't destroy anything but electronics. Thank you.
Thank you everyone for joining us. Now I would like to request Shri Amit Saxena, Scientist E, C-DAC Pune, to kindly felicitate Colonel Retired A.K. Nath. Shri Amit Srivastava, Scientist E, C-DAC Pune, to kindly felicitate Shri Rahul Neiwal. Symposium. As we bring this event to a close, I'd like to say what a privilege it has been to witness such a confluence of brilliant minds sharing knowledge and ideas. A heartfelt thanks to our distinguished speakers, panelists, and our esteemed moderator, Colonel Retired A.K. Nath, for their invaluable insights. Your expertise has left us all enriched and motivated. I would also like to extend my gratitude to organizers, volunteers, and everyone working behind the scenes for making this event seamless and memorable. To our wonderful audience, thank you for your enthusiasm, curiosity, and thoughtful participation. Your engagement has added immense value to this event. As we conclude, let's carry forward the energy and inspiration from today, striving to contribute to these transformative fields in our own unique way. On behalf of the entire team, I thank you all once again and wish you a great day ahead. Stay curious, stay inspired, and until next time, thank you and goodbye. Now, I would like to request only the registered participants to kindly collect certificate from us after the tea break.